So question 1, the goal is to produce a plot that looks like this, that shows a scatter plot with a superimposed line plot. Now, as is mentioned, this probably is not an appropriate use of a line plot, but I just wanted to stick with the data frame MPG, so that's why we're using this plot. So, what are we going to have? On the x-axis, we're going to have cylinder. And then we're going to have two separate lines corresponding to two of the 5 fuels, premium and regular. And for each combination of cylinder and fuel type, what I want to do is calculate the average city mileage, and that's what's going to go on the y-axis. So we've got both geom line and geom point happening here. So if we think first about geom line, there's going to be both some mapping and some setting. So in terms of the mapping, what sort of mapping is going to be involved? So on the x-axis, there's going to be cylinder. On the y-axis, there's going to be city average, map color, on the fuel, and you probably want to get group equals fuel, so you get different lines for the two different fuels. There's also going to be some setting, and that the line type equals 3, and the size equals 3. So that's the line plot. And then there's going to be a scatter plot, and the scatter plot is going to be produced by geom point. Scatter plot is going to be produced by geom point. And once again, there's going to be both some mapping and some setting. So in terms of the mapping, as was the case for geom line, X is going to be equal to cylinder, Y is going to be equal to city average. You're going to map color on a fuel. And now there's going to be some setting. What are we going to do in setting for geom point? We're going to set the size equal to 6. So, how operationally are you going to go about doing this? Well, the first thing you're going to need to do is you only want these two fuels. So you're going to begin by filtering. So the fuel is going to be equal to either premium or regular. Now, what I just wrote, that isn't going to run. What I've written here, and I'll be doing that throughout these labs, is what I would consider to be pseudocode. It's meant to provide some information on what you meant to do, but it isn't actually going to run if you typed it in and hit the run button. So you begin by filtering. So you've only got those two fuels that you're interested in. And then what you're going to do next is you're going to group by cylinder and fuel. Continue on with the piping operator, and then use the summarize function. Use the summarize function to get the average city mileage. And then at that point, what will you have? What will your data frame consist of once you've done all this? Well, how many records you'll have? You'll have one record for each of the different levels and the combinations of the grouping. So you're going to have a total, if you consider the different combinations of cylinder and fuel, you're going to have 7 records. How many variables? The variables, you're going to have 3 variables. The only variables present are those specified in the grouping function or created by the summarize function. So you're going to have 3 variables: cylinder, fuel, and city average. And that should be enough to make this plot. So in the second question, you're going to make 2 separate plots, and then you're going to combine them with grid arrange. So the first plot that you're going to make is going to use the same data frame as was used in the previous question, as in question 1, and you're going to create an object that would make this plot. And we're going to have this object named base, and essentially it's the same thing as the line plot portion, from the previous question. And then you're going to make another plot, and the name of that other plot is going to be full plot. And how are you going to do that? You're going to make it by starting off with the object base that you just created, and then you're going to add to it geonPoint, essentially the same code as previous question. So see question 1 to get the code for geonPoint, and then you're going to combine with the grid arrange function. So, fairly simple question. That was question 2. This is a plot to be produced for question 3, and it involves binning. So the idea is they're going to be created 7 bins based on city mileage. And for each one of those 7 bins, going to calculate 3 summary statistics. The average highway mileage, the average city mileage, and the count of records associated with each bin. And then X is going to be mapped onto the city average, Y is going to be mapped onto the highway average, and size is going to be mapped onto the variable count, the number of observations associated with each bin. So how are you going to go about doing this? First thing you got to do is create those bins. And so the way you create a new variable, in this case bin, is to use the mutate function. It's going to use mutate to create a new variable called bin. And remember, when you use mutate to create something, when you're creating bins with mutate, 3 things you need to specify: type of bin, number of bins, the variable upon which it's based. So in terms of the type of bin, what we're going to use is cut number. So it'll give us bins with approximately the same number of observations in each bin. How many bins do we want? We want n is equal to 7. And what's the variable upon which these bins are based? These bins are based on city mileage. So if you think what you'd have after this step, what you'd have after this step would be a data frame that would have 234 records. So to have all 234 records of MPG, and it would have this new variable bin, which is created by the mutate function. So then what you do is you continue on and you group by bin. And then there's our piping operator. Use the summarize function to create these 3 new variables: city average, highway average, and count. And again, this isn't real code. This is just pseudo code to give you some idea what you're going to do. Once you've done that, you've got enough data so that you can make the plot. And then in terms of the markers, you're going to do some setting. These markers, you're going to set the shape equal to 13. And the color is going to equal purple. And the size, you're going to map size onto count. So you get different size markers depending upon the number of different observations in each one of these bins, each one of these combinations of city and highway mileage. Okay, that's question 3. This plot, the answer to question 4, has 3 different manufacturers. And for each one of those 3 different manufacturers, what goes on the x-axis, city mileage. What goes on the y-axis is highway mileage. So we got the 3 different manufacturers distinguished by their colors, and the size of the marker is going to be determined by the number of observations associated with the manufacturer. So in terms of the Jeep is going to have, there's 5 observations here. It's going to have a size of 5. Up here you've got 9 observations, so all these guys are going to have a size of 9. And down here you got 8 observations, so all those would be a size of 8. So how are you going to do this? First thing you're going to do is just filter to retain the 3 manufacturers. That you desire. And then you're going to group by manufacturer. And use the mutate function to create a new variable called count, which is going to be the number of observations associated with each manufacturer. And that's because you've, maybe write this out, that's because you've grouped by manufacturer. So if you think what the data frame is going to look like at this point, what you're going to have is number of records, and there will be 9 plus 5 plus 8. You have 22 records. And let's say we look first at the Jeep. You might have, for example, a city mileage value, and a highway mileage value. And you could have numbers like 14 and 17, or values like 15 and 20. All sorts of these things. But the Jeep, because you've grouped by and mutate, all these values are going to have a count of, being that it's a Jeep, the Jeep is going to have 8. And similarly, if we think perhaps of the Honda, we might have values in the Honda like 2435 and 2634, but all the Hondas are going to have counts of 9. So that's the data frame. It's going to be used to make this plot. In terms of setting and mapping, what sort of mapping is going to be involved? Well, obviously you're going to map X onto city, Y onto highway, but you're also going to map color on a manufacturer. There's going to be some setting. What sort of setting is going to happen? You're going to set the shape equal to 21. So you're going to set shape is equal to 21, which is a circle with a border. So you know the internal color, the predominant color, is going to be determined by manufacturer. The outer color is going to be determined by setting color equals purple. And then finally, when you're done, you can use scale, size, continuous to get a range of marker sizes that goes between 4 and 8. So that's question 4. The last question is based on this data frame here that you'll need to import. And what you have are 14 different seed sources. So there's 14 different seed sources, 1 record per seed source, so you got 14 records. 14 records. And what you've got is a bunch of seed sources that are classified by their location, either south or north. And each one of those seed sources, little trees were planted out, and you got measurements of at different times, different ages. And what you have in the body of the table are the heights of these trees at different ages. So that's what you got. And the goal is to produce this plot, which shows for the different ages of the trees what their height would be. There are 14 different lines. One per seed source. And they're colored by location, either north or south. So, first thing you got to do is convert the initial data frame, which is in this wide form, to a data frame that's in the long form. The function to do that is going to be the gather function, which is associated with the tidyr package. So remember, when you use gather, there's three different arguments. First, what are the variable names that get gathered together and stuck in a column? The variable names that get gathered together and stuck in a column are T03 to T25. Then, when these things here get stuck into a column, that column needs a name. So you can say that key is going to be equal to age, perhaps. And when these values here get stuck into the column, all the values in the body of the table go into an adjacent column. That adjacent column requires a name, so you can say that value is equal to height. So you do all that, and you're almost there, but the problem is this variable age is a character, and so what you want to do is change that from a character into a numeric value. So how are you going to do that? You're going to use a lookup table. So you've got a lookup table. Looks like that. You bring the lookup table in, and you add these two together. You add this guy and this guy together using the full join function. And what that will give you is this initial table is now going to have a new variable called age 1 that it got from the lookup table. So now you've got the data frame that's necessary in order to make this plot. After that, it's pretty straightforward. The only other thing to add, perhaps, is that what you're going to need to do is, obviously, in your line plot, you're going to map color onto location. But you probably also want to use a mapping of group equals on the seed, so you get 14 lines for the 14 different seeds. So that would be the final question.